All right, let's jump right in. Ever wonder what's really going on behind the screen of your phone or your laptop? Well, today we're going to pull back the curtain and look at the hidden languages that run our entire digital world. We're going to explore how computers actually think, and believe it or not, by the end of this, you'll be able to speak their language too. Let's get to it.
I know. It sounds like something straight out of a sci-fi movie, right? But what if I told you that it's totally possible? That by the end of this quick explainer, you'll have the basic tools to see the digital world not how we see it, but how a machine does.
And that's really the whole secret. It isn't some kind of magic. It's just a language. A language that isn't built on words and letters, but on numbers. And as we'll see, there are 3 key number systems that make our digital reality tick.
And wow, okay. This slide really lays it all out for us, doesn't it? You've got one single value, 192, shown in 3 completely different ways. We humans, we think in decimal. That's our comfort zone. Computers, though, they operate purely in binary, those long strings of ones and zeros. And then you've got hexadecimal, which programmers use as a kind of convenient shorthand. Our goal here is to become fluent translators between all 3.
So, let's open up our digital toolbox and grab the very first tool. This one is all about taking our numbers and teaching them to the computer. How do we translate a number we understand, like 192, into something a machine can process? The method we're going to use is called successive division. And trust me, it sounds way more complicated than it actually is. You literally just divide, write down the remainder, and do it again. The only real trick, the thing you have to remember, is that last step. You read your list of remainders from the bottom to the top. Let's see it in action.
Okay, so let's convert 192 into binary. We're just going to keep dividing by 2. So 192 divided by 2 is 96 with a remainder of 0. Got it. Then 96 divided by 2 is 48, remainder 0. And we just keep doing this all the way down the line until our main number, the quotient, hits 0. Now for the magic trick, read those remainders from the bottom up. What do you get? 1, 1, 0, 0, 0, 0, 0, 0. There it is, 1, 1, 0, 0, 0, 0, 0.
Just a quick heads up when you're converting to hexadecimal. Because it's a base 16 system, you can actually get remainders all the way up to 15. So what happens if you get a 10? Well, we don't write 10. Instead, we use letters as placeholders. So 10 becomes A, 11 is B, all the way up to 15, which is F. It's just a simple swap.
All right, tool 1 is in the bag. Now for our second tool, we're going to flip the script completely. This time, we're going to learn how to take what the computer is saying and translate it back into a language that we can actually understand.
So the big idea here is something called positional weighting. And it's actually super intuitive. Just think about the number 111. Even though it's the same digit, each one means something different, right? You have 100, you have 10, and you have 1. It's the same exact principle in binary or hex. Each position has a specific value, a power of its base, starting from 0 on the right-hand side. So for binary, the formula is pretty straightforward. You just take each individual digit, which we call a bit, multiply it by 2 raised to the power of its position in the line, and then you just add all those results up.
And you know what's great? For hexadecimal, it's the exact same logic. The only thing you change is the base. Instead of 2, you're multiplying each digit by 16 to the power of its position. Same idea, just a different base number.
All right, tool number 3. Now this is the good stuff. This is the pro-level shortcut. This is how you can jump between the computer's native language and the programmer's shorthand without all that messy math in between. Seriously? Converting from binary to decimal and then over to hex? I mean, it works, but it's slow and clunky. There is a much cleaner, more elegant way to do it. Meet the 4-bit grouping method. The whole thing is based on the number 4. And you might be asking, why 4? Well, because 2 to the power of 4 is 16, which just so happens to be the base for hexadecimal. That direct mathematical link is the secret. It means we can just break a binary string into little chunks of 4 and convert each chunk on its own.
Let's go back to our old friend, 11100. How do we turn this into hex in just a couple of seconds? Okay, step 1. Starting from the right, you just chop it into groups of 4. That's it. So we get one group that's 1100 and a second group that's 0000. 2 perfect little 4-bit chunks. And now we just translate each chunk individually. That first group, 1100, is the binary for the number 12. And we know from our little chart that 12 in hex is C. The second group, 0, 0, 0. Well, that's just 0. You stick them together, and you get C0. Boom. Done. No long division required.
Okay, we've collected all our tools. Now it's time for the final project. We are going to put everything we've learned to work on something that you probably see every single day, whether you realize it or not, an IP address. The first thing you have to understand about an IP address like this one is that it's a bit of a lie. It's not one giant number. It's actually 4 totally separate 8-bit numbers, called octets, that are just separated by dots. So our mission is simple. We just have to convert each one of those 4 numbers one by one.
First up, 192. Hey, we've seen that one before. We already did the hard work. Using our division method, we know that translates perfectly to 11000000 in binary. See? 1 down, 3 to go.
Next is 168. We just run it through that same division process, and out comes its 8-bit binary equivalent, 10101000. Easy enough. The third octet is just the number 1. Now this one seems simple, but there's a small catch. To be a proper 8-bit number, an octet, it has to have all 8 digits. So it's not just 1, it's 7 zeros followed by a 1.
And the final octet is, well, it's 1 again. So we know the pattern. And just like that, with that last piece in place, we've done it. You just took a normal, human-readable IP address and translated it into the full 32-bit binary string that a computer actually understands.
Okay, this little reference table here, this is where it all clicks into place. Take a look at that last row. The absolute biggest number you can make with 8 bits, a string of all ones, is 255 in decimal. That is why you've never ever seen a number in an IP address higher than 255. It's not a rule someone made up, it's a hard limit baked into the binary code itself.
So just take a second to think about what you just accomplished. You didn't just convert some random numbers. You took a common piece of digital information and read it in its native language. This is the bedrock, the foundation for understanding everything from the color codes on a website to the raw data inside your files. The only question now is, what will you decode next?